Welcome back, everyone. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, broadcasting in Apple Valley, California. Scott, we had one of our listeners say they're from Hesperia.
Oh, cool.
I didn't recognize the name, but yeah, so we got locals watching us.
All right, nice.
Yeah,
Nice.
and we are the Science and Technology Channel. Got something interesting today, this afternoon. Scientists are investigating Saturn's moon Titan to understand how tidal forces affect its orbit, revealing clues about its internal structure and past changes. This research indicates Titan's orbit is evolving rapidly on a geologic timescale, implying an event within the last 350 million years disturbed its once stable path. Whether caused by an impact or another celestial event, the findings suggest Titan is still settling into a circular orbit, leaving scientists with an unfolding mystery about its recent past. Scientists posit their ideas in a paper on this topic published in the journal Science Advances. Would you like to know more? I think we did a segment
On the that
What is
touched on these moons.
where
Right?
where the moon hits Saturn and then they're tidally locked. Is that
Was
that
I
Neptune?
think that's what the theory was. But yeah, it's kind of weird, right? So it's instead of a baseball spinning towards the batter, being thrown out, it's almost like what is that pitch? Is that a knuckleball that doesn't spin, right?
Right, doesn't spin.
Yeah. So and I'm definitely not a baseball expert, so let us know if I'm wrong. But I think it's a knuckleball. And so I'm kind of envisioning that, right? This moon is just like spinning around, not spinning. I mean, it's moving around the Saturn, but it's not
I
spinning.
think they're moving together, aren't they?
Yeah, that's just I don't know.
That's why it's
Kinda
tidally locked.
Interesting. So,
Like that.
Southwest Research Institute scientists are investigating how Saturn's moon Titan loses energy as it orbits the planet, a process known as tidal dissipation.
Dissipation.
This loss of energy caused by Saturn's immense gravitational pull provides key insights into Titan's eternal structure and its orbital evolution over time. Quote, when most people think of tides, they think of the movement of the oceans
Yep.
in and out, with the passage of the moon overhead, right?
That's what causes the tides.
Exactly. And that's from Dr. Brianna Downey. To go on with a quote, but that is just because water moves more freely than anything else. When the moon passes overhead, the rock is also responding. Interesting.
Yeah, that is interesting.
Yeah, just less perceptively. But that little bit of gravity that the moon is imposing is what we call tidal dissipation.
Yeah, I never thought of that affecting the dirt and the rocks.
I
never thought of
that. I guess it would, but yeah, I mean, obviously it's more pronounced with the ocean because you see that. You notice it. Low tide, high tide. So yeah, interesting.
Yeah, water moves a lot freer than dust and rocks. Yeah.
Rocks, yeah.
On Earth's moon, scientists measure tidal dissipation by bouncing lasers off mirrors placed on its surface. So now we have proof that the moon landing was not filmed on a soundstage. If we got mirrors up there and we're bouncing lasers off, no way it could have been staged.
You need a proof of that?
No, there's others out there that say it was staged. It's a conspiracy.
And they're crazy.
And
they're not crazy, but to think that, it's like the flat earthers, right? They're just, come on. But anyway.
Since you brought it up,
okay.
One of my buddies, he's a flat earther, and he thinks that, there's edges, finite edges. And so I said, well, you see the moon, right? It's circular, right? And I said, well, that has to be flat too. He said, no, that's a sphere up there. I said, no, if the earth is flat, the moon has to be flat. The sun has to be flat. Okay. It blew his mind, man. His mind.
So not to just dwell on that, but if you're on a cruise ship, and there are cruise ships that cruise across the Atlantic or the Pacific to Europe or to Asia, right? There's ships, cruise ships and cargo ships.
Mm-hmm.
What happens to them?
They fall off, man.
Well, and okay, then what happens to that cargo?
They can't tell you.
Is it missing?
The flat earthers can't tell you, man. They just go in a circle.
Or do they do the 90-degree downturn or whatever? I don't know. That's just bizarre to me. But
okay,
whatever.
Lasers bouncing off the surface, detecting tiny shifts in movement. Since this method isn't possible on Titan, I guess Not because it's too far away, it's because we don't have mirrors on it, right?
Right.
I don't think distance is a problem. Researchers instead estimate the effect by analyzing subtle variations in the moon's spin axis, differences that wouldn't exist if tidal forces weren't at play.
Quote, we got tidal dissipation in satellites affects their orbital and rotational evolution and their ability to maintain subsurface oceans. That's according to Downey. To go on with the quote, now that we have an estimate for the strength of tides on Titan, what does it tell us about how quickly the orbit is changing? What we discovered is that it's changing very quickly on a geologic time scale.
Okay, so I mean, geologic, talking billions of years.
Well, what are we talking? Like 350 million years, they said, right? Since the last.
Within,
yeah. So
is that
that's a big
quick?
window.
Is that a quick geological time scale? 350 million, I guess. Downey, a postdoctoral researcher at SWRI's Solar Systems Science and Exploration Division in Boulder, Colorado, and her co-author, Dr. Francis Ninmo of the University of California, Santa Cruz, consider that the angle of Titan's spin pole orientation can only be due to friction and deduced a way to relate this angle to a tidal friction parameter. What? I just hissed and booed.
It's all right. It's okay.
UC Santa Cruz. Okay.
Just about any of the UC chains are kind of buoy, but whatever. Anyway.
Their mascot is the banana slug. The banana slug.
Santa Cruz, UC Santa Cruz?
Yeah.
Banana slug.
Yeah.
Oh my gosh.
That thing is long and it's yellow.
Yeah. It could have done better than that. So
very
slow.
Very slow, yeah. In this way, they were able to deduce some of the history of Titan from its current spin state, with future space missions planned to various moons such as Europa and Ganymede. We've talked about that.
We have talked about
Ganymede. Very exciting.
Yep.
Very exciting. 2 moons of Jupiter. Downey hopes that this method can be applied to other moons as well.
Friction in a satellite's interior causes it to slowly progress towards a circular orbit. At the rate its orbit is changing, Titan should have acquired a circular orbit within about 350 million years. Not trying to speed up the process at all, right? The fact that Titan currently has a non-circular or eccentric orbit implies that something occurred within the past 350 million years that perturbed its orbit. Interesting. Something made it mad, I guess, right?
Maybe
it's having an orbital tantrum.
Maybe.
I don't know. It's funny. You know, what the heck? Maybe, I don't know.
Well, let's see what they say. Quote, any number of things such as an impact or loss of an ancient satellite, so another moon moving out, could have affected the orbit and made it eccentric. Our findings are agnostic as to the nature of the event, and others have proposed several options, Downey said. The bottom line is that we think something has disturbed Titan's orbit within the last 350 million years, which is relatively recent in solar system history. We're looking at a snapshot in time between that event and the point when it reaches a circular orbit again.
Okay, I just had this thought. So, you know, when you have a hard-boiled egg in the refrigerator and you have a raw egg in the refrigerator, both in their shell.
One each, yeah.
And you need to figure out which one is which. What do? You roll it across the table. And the hard-boiled egg will roll and spin, right? Soft-boiled, or the egg that's raw, stops.
Where? How far?
Not very far. It doesn't spin. You can test that.
The inertia inside of the yolk?
Exactly. It'll just stop the egg dead in its tracks.
Huh.
Maybe it's got something soft in the middle. Maybe there's some kind of water or gel or molten or lava or something.
Did you research this when you got
I
the
just thought of
notes?
that. I just thought of that. Why is this thing not orbiting? Why is it not spinning when it orbits? I mean, that's just not a natural.
Maybe it's got like some type of weird core. Is what?
Yeah,
what
that's
you're
what I'm
saying?
saying. Maybe it's got some kind of an egg type core where it's just. It won't allow it to spin.
Titan's a huge egg, a giant egg. Well, you
Yeah.
can't make an omelet without cracking eggs, right?
That's correct.
Okay. Thank you, folks, for joining us. We'll catch you in the morning.
Take care, everyone.